Welcome back to Moose and Chemistry. Today's lesson will be on Charles' gas law. So Charles' law is going to be V1 over T1 equals V2 over T2. But there's a better way to write it. I like to write it as V1 T2 equals V2 T1. Now, Charles' law is a comparison between volume and temperature, the relationship, where the constant in this case is pressure. Pressure does not change. Also, temperature must be in Kelvin when using Charles' law. If you have Celsius and you want to convert it to Kelvin, so how do you change Celsius? You change Celsius to Kelvin? Simple. Kelvin equals Celsius plus 273.15. Now, given that, let's write our first problem. All right, our first problem. A man heats a balloon in an oven, which is kind of a weird thing. If the balloon initially has a volume of 0.4 liters and a temperature of 20 degrees Celsius, what will the volume of the balloon be after he hits it to a temperature of 250 degrees Celsius? It'll probably be burned up, but let's go ahead and solve the problem anyway. So first of all, what we want to do is we want to find our values. So V1, T1, V2, T2. So we're going to go ahead and set up our volumes here. Our first volume is 0.4 liters. Our first temperature was 20 degrees Celsius, but we're going to need to change that. Our second volume is what we're looking for, and our second temperature is 250 degrees Celsius. So let's go ahead and convert our temperatures. So we're going to look at T1. So K equals C plus 273.15. So K equals 20 degrees Celsius plus 273.15. So that tells me that this is 293.15 K. Temperature 2, using the same formula, K equals C plus 273.15. So we're going to go ahead and put in 250 degrees Celsius plus 273.15. And now our new temperature is going to be, one moment, the new total is 523.15 K, 523.15 Kelvin. Notice that we don't use the degree sign with Kelvin. So now let's go ahead and set up our original Boyle's law, V1 over T1 equals V2 over T2. Now we're going to go V1 T2 equals V2 T1. Now we want to isolate for V2, so V2 equals V1 over T2 divided by T1. So now we're going to put our values in. V2 equals, our first volume was 0.4 liters times our temperature 2, which was 523 K. K, right? And then we're going to put our second temperature, which is our first temperature, underneath, which would give me 293.15 K. Our K's cancel out, so let's go ahead and do our calculations. So we get 0.4 times 523. Divided by 293.15, and we get a total volume of 0.71 liters. So that answer is good. So we're going to go ahead and get ready to do our second problem. First, I'm going to erase all our previous drawings. So now in our second problem, we have a different situation. On hot days, you may have noticed that potato chip bags seem to inflate even though they have not been opened. If I have a 250 milliliter bag at a temperature of 19 degrees Celsius and leave it in my car which has a temperature of 60 degrees Celsius, what will the new volume of the bag be? Well, let's go ahead and figure out what we have first. So our first bag has a 250 milliliter volume and the temperature is 19 degrees Celsius. We're looking for our new volume, so that will put a question mark there, and our second temperature is 60 degrees Celsius. So the first thing you have to do is convert our Celsius into Kelvin. So for T1, we're going to say K equals C plus 273.15. So that gives us that K equals 19 plus 273.15. So K is equal to 292.15 K. Okay, our T2 equals K equals C plus 273.15. So we go ahead and put in 60 there, plus 273.15, and our new value is going to be 333.15 K. Now what we're going to do is we're going to set up the problem. So we want to isolate for V2. So V2 equals V1 over T2 over T1. So we put our values in. Our V1 value now is 250 milliliters. It's okay to leave it in milliliters. Our T2 temperature is going to be 333.15 K divided by our T1 temperature, which is 292.15 K. Our K's will cancel out. V2 equals, so take 250 times 333.15. Okay, so we're going to get that number in one moment. Divided by 292.15, and our new volume is going to be 285.08 milliliters. And that's a good answer. So you guys have an amazing day and try some of these problems on your own.